First of all, hello everyone and good day. So during the approximately 30 minutes, I'm going to present our view and experience in Openwave about this fascinating topic of automation in the complex platforms of communication services in telcos. I'm going to share our point of view as a vendor of technology, as Annie just mentioned. And then at the end, we'll run a brief demo of our system, showcasing a real life scenario. We'll get a bit deep technically on that demo. Okay, so my name is, as Annie mentioned, is Estanislao Utrilla, and I am Vice President of Customer Support and Operations at Openwave. I started working in Openwave about 25 years ago in various technical functions. I took a more leadership role about 15 years ago, and more recently, I started overseeing the global customer support and operations teams in charge of our managed services and SaaS platforms in Openwave. I've always been very interested about exploring new ways to improve how we work. And I really believe that AI-driven automation is nowadays representing one of the most exciting opportunities to do just that. But first of all, a little bit about us, Openwave. So in Openwave, we provide a white label email and messaging platform for communication service providers to deliver trusted communications in any channel. Our strength comes basically from a deep domain expertise and real commitment to customer success that our teams are demonstrating every day. So we've been in this industry for a long time, and during this time we have established long-term partnerships with our telco customers over the years, and through these partnerships we have worked hand in hand with them, with our customers, to solve tough problems and challenges in areas like customer engagement, monetization, service reliability, and digital transformation. And to unlock new opportunities like currently the topic of this presentation, optimizing operational efficiency through automation. So collectively, the Openwave platforms manage and protect over 300 million registered messaging subscribers and handle over 5 billion messages per day. Our largest deployments, which are the largest existing telco email platforms, have more than 50 million users, and they have up to 5 nines of availability. Okay, so let's start with the topic of this talk by reviewing the current situation that we observe in the messaging platforms that we support and manage in Openwave. In all of them, we see already a significant level of automation in many operational areas. Much of this automation is in the form of rule-based scripts and workflows, but also some processes like anomaly detection or spam filtering use machine learning and different techniques of traditional AI. However, despite all this progress, running an email service remains highly labor intensive. It still requires skilled engineers to keep services running smoothly and to defend against the constant threats that we are seeing every day. And this is exactly where the latest advancements in AI come in. So as we know, in every DevOps organization responsible for keeping critical digital services, such as messaging platforms, running smoothly, a key goal is to reduce the resolution time and in parallel the cost to run the operations. So if we look at a typical pyramid of a DevOps structure, with the biggest expertise at the top and the more routine type of work handled at the base, the most efficient organizations improve resolution time and reduce cost by continuously shifting work downward, empowering the lower levels through automation, tooling, and self-service. So today, with these rapid advancements in AI that we are seeing, the potential to automate a large portion of the operational tasks is huge. So the latest AI systems are now proving that have the potential to perform many activities that today require highly skilled engineers. So we believe that this transformation is going to allow us to free human expertise to focus more on innovation, continuous improvement, and business growth, rather than the repetitive operational firefighting. So we know the motivation for AI ops, and we know that it is about taking automation in operations to the next level. So let me just use one example that helps illustrate both the potential and the end goal that we are working to achieve. So think about a system that either proactively or in response to a customer complaint detects a deviation or anomaly from its functional specifications. The system automatically reproduces the behavior in a control environment to confirm that it's repeatable and to capture all the additional details, such as logs, configurations, and runtime conditions. It then analyzes the relevant sections of code to identify the source of the defect. Once located, the system modifies the code, builds the code, and redeploys it in the control environment. Then it verifies the fix and run an automated regression test suite. And after successful testing, it promotes the build to lab and pre-production environments, and then performs further verification there. And finally, the system creates a change request, answers any questions about the change, like if there is any expected downtime, the risk of the change, waits for human approval and a scheduled maintenance window, and then executes the production deployment pipeline. The new version is first rolled out to a single canary container for post-change testing. It soaks there for a few days, and then once it's fully validated, it is gradually deployed across the entire platform. Okay, so there's nothing really new here. I mean, these are exactly the same steps performed by a team of DevOps engineers over the course of hours, days, or weeks, depending on the severity of the issue. The only difference is that today, automation covers only some fraction of this process. Basically, some parts of the CI/CD pipeline, like testing or some of the deployment automation, but there is still a large amount of human effort required throughout the entire process. So I don't want to imply that the full end-to-end self-healing and in general fully autonomous operations, what is called no ops or zero ops, is going to be easy to achieve, but it's certainly a realistic target with the current state of the technology, and especially with the capabilities of generative AI. Okay, so why generative AI is changing the game? So I'm going to show there some key reasons for that. So first, advanced natural language processing. So everyone using the conversational AI platforms like ChatGPT, Google Gemini, Microsoft Copilot, and others is very familiar already with the impressive natural language capabilities of the large language models. In our context, these capabilities enable us to interact with the system, for example, just by asking questions like, hey, what are the possible causes of this error in the log? Instead of the traditional interaction through scripts, database queries, regular expressions, etc. So now autonomous agents. So probably this is the main feature of agents, is that they can reason, plan, act by executing tasks, and replan based on the observations from those tasks, collaborate with other agents, and keep iterating in this loop until they achieve the goal that they have been given. So let me repeat here again, because this is exactly what makes agentic AI so powerful. So agents are given tasks and objectives, and in order to achieve them, they reason, they make plans, they act, taking actions, they analyze the observations of those actions, and they collaborate with other agents, pretty much mimicking what we humans do to perform the same tasks. So, I mean, I don't know about you, but to me, it doesn't stop amazing me how all these capabilities are just due to the deep statistical structure and correlations of the trillions of words that LLMs have been trained on, right? So from books, web pages, articles, dialogues, in internet, etc., etc., etc. The LLMs have acquired all these capabilities. Okay, so next is knowledge integration. So as you know, with retrieval augmented generation, agents can access to vast knowledge bases in real time with manuals, incident history, knowledge articles, technical documentation, etc. Adaptability. So this is about being able, through reasoning, to respond to new or unseen problems without previous knowledge or previous retraining. A traditional AI system, a rule-based traditional AI system would be very limited to handle completely new situations. So let alone a deterministic system for which the specific rule doesn't exist yet. So this is a key capability of generative AI. Continuous learning is the ability of the system to improve over time from feedback, new data that is receiving, reinforcement learning, etc., etc. And finally, decision support is basically the ability of the system to explain the chain of thoughts that led the system to take a certain decision. So we are going to see all these features in action during the demo that we'll see at the end. To do that, let's now look at some practical applications. So one of the first and most mature applications of AI agents, as you know, is in customer and end user support. So this use case has been widely adopted already by many companies in the telco industry, in retailers, in banks, airlines, etc., to provide faster and more efficient service, and at the same time reducing the cost of the call centers. The traditional chatbots that are built on intent-based models were often very limited and rigid. But with generative AI, the capabilities have increased by orders of magnitude, enabling more natural, context-aware, and adaptive conversations. So in this slide, we are showing here in the left, the typical use of the system. This is a web interface, the typical chatbot. And in the right, our framework for end-user agents, which is essentially very similar to other agent-based frameworks for customer support. When we combined typical chat interface via web or mobile app with other channels like voice, we believe that the potential to offer a great end-user service and experience is huge. And we have set our goal for this system is to be able to handle autonomously and to full customer satisfaction more than 60% of the calls to the call center that the email service provider is receiving today. But AI-powered service agents are just the beginning. So the next step is AIOps. So as we have mentioned, AIOps is about leveraging the latest breakthroughs in AI to mimic as much as possible what human experts do on a daily basis to operate very complex platforms. The goal is to get experts focused on driving value and innovation, while at the same time, as we said before, reduce cost and improve resolution time. So in the following slides, we are going to walk through a few important lessons that we have learned along the way in our AIOps journey. So based on this, we are now starting to work with our customers to trial the benefits of AIOps through proof of concepts. So first, AIOps is orders of magnitude more complex than customer support agents. So the inputs available to an AIOps system, the logs, metrics, traces, config, alerts, events, are vast. And the system it operates on has many degrees of freedom. Investigating a single alert or anomaly may require access to the platform's full telemetry and can branch into dozens or even hundreds of checks and actions just to identify a root cause and fix it. Where customer support agents usually answer questions or execute a predefined sequence of steps, AIOps agents must handle much more complex, longer-running tasks, often with the uncertainty of not having prior examples of the exact problem. Because of that, we need capabilities beyond those in standard React-style agents. As you know, React is a basic paradigm of agents, which comes from their ability to reason and act. So these new capabilities are the following ones here. So first, divide and conquer with multi-agent architectures. So the more we are able to break down a task, the better an agent will perform. For example, if the system needs to investigate an anomaly on an IMAP KPI, a central supervisor agent could delegate the job to a specialized IMAP troubleshooting agent. That agent would have access to the IMAP functional specifications and IMAP-specific telemetry and diagnosis actions. If during the investigation, code inspection is needed to understand under which conditions a certain log event is triggered, the IMAP troubleshooting agent could in turn consult a group of IMAP code specialist agents. It's focused on a specific logical component. The bottom line is, to make agents effective, we must give them well-defined roles, clear scopes of responsibility, access to the right domain knowledge, and only to the domain knowledge that they need to perform their task. This way, they can collaborate like a team of focused experts, each contributing their part to solve the problem. So the whole idea that we are describing here is basically about context isolation. Then more control planning. So the complex and long-running tasks required on AIOps make agents vulnerable to losing track of earlier objectives. So for this reason, we need a more formal approach to keep the agents focused and on track, maintaining focus on the main objective and preventing mission drift. So we achieve this by keeping formal planning or to-do lists and forcing the agent to revisit, validate, and update these lists regularly at each step of the process. Now, keep only the minimal working context in memory. For example, imagine that the agent queries system traces over a certain period of time. Keeping that output in the context window, in addition to all other observations, domain knowledge, etc., would soon overwhelm the context window in long-running complex investigations. The idea is just to offload infrequently used context, get only the high-level summaries in the context window, and fetch the detailed data on demand just when needed during the investigation. So all these three capabilities that we have just mentioned are the defining characteristics of the so-called deep agents, which is a term coming from the latest progress made by companies like OpenAI and Anthropic in the area of research and code agents. So next, very careful prompt and context engineering. So as with the standard agents, but even more crucial here in AIOps, extensive and precise prompts and guardrails are needed to steer behavior to ensure safety, enforce operational constraints, prevent hallucination, etc. So in addition to prompt engineering, context engineering is also critical in AIOps. Context engineering is designing what the agent holds in its context window at each step of the process to allow the LLM to perform optimally. So it is basically about the capabilities that we have just seen, isolating context with specialized agents and offloading context from memory. Now, and automation strategy is essential. So not all tasks are best solved the same way. So some are more efficient with rule-based scripts or traditional AI, and others require the reasoning and adaptability of generative AI. So an effective AIOps platform, and this is very important, must take a hybrid approach, combining these methods to get the best result in the most efficient way. We cannot just use AI, generative AI for everything, because that will not work. And define a knowledge strategy. So this knowledge strategy is another critical area. An AIOps system is designed to make decisions under uncertainty, often without prior experience. But any domain knowledge that we inject, whether through retrieval augmented generation or fine-tuning the language model, can greatly improve the system's ability to resolve problems effectively. So that's why a key element of the system is its ability to learn from its own experience, so that over time it becomes smarter, faster, and more reliable. Data. So data quality is key, and an important step is to pre-process or prepare the data from the different sources before prompting. So that includes filtering noise, aggregating and correlating, adding any relevant context and information like anomaly analysis based on historical data, etc. For example, if we injected the thousands of alerts that can trigger from a platform incident without any pre-processing, we will very easily overwhelm an agent. And also, when analyzing anomalies, it is key to add capabilities to the system to distinguish between correlation and causation. For example, by providing causal graphs as part of the context. On the other hand, we must always keep data privacy in mind. So that means using local language models when possible, and applying obfuscation techniques to protect sensitive information. And finally, benchmarking. Benchmarking is also essential in AIOps. So unlike traditional software, the output of an AI system is non-deterministic. With the same input, it might sometimes choose one approach and other times choose a different approach, taking more steps or even failing to resolve the problem. So that's why exhaustive benchmarking is important, not only as a one-time exercise, but every time that there is a design decision, like creating additional agents or adjusting the way they are prompted, the context they are given, etc. So benchmarking helps us define clear success criteria, build trust in the system, and gradually increase its level of autonomy. And as we give systems more autonomy in operations, trust and governance become key. The first question is, how much autonomy do we allow the system to have? Here we need to find the right balance between efficiency and control. And for example, in many cases, we will need to keep a human in the loop to approve or validate sensitive actions, ensuring accountability. And guardrails become critical. So guardrails define, as you know, policies, limits, and the monitoring mechanisms so that AI operates safely within trusted boundaries. Okay, so in order to illustrate most of the points that we've discussed in this presentation, we present here a real-life scenario using our AIOps pilot. So by following the logs of the system, we can observe the reasoning actions and decisions performed. The demo highlights key aspects. First, how the system is able to formulate sound hypotheses based on the evidence it gathers and its knowledge of the platform. Second, how it chooses the right tools at each stage of the reasoning process. Third, how different agents collaborate among each other in a multi-agent architecture. Fourth, how the system connects the dots and develops a theory, very much like a human expert would do. And according to our benchmarks for this particular scenario, the system meets all the target success criteria more than 90% of the times without injecting previous knowledge, and 100% of the times with prior knowledge. And fifth, how the demo is run without providing any prior knowledge of the issue, simulating a first-time incident. This is the adaptability feature that we saw before. And finally, how the system captures the key learnings and stores them in the knowledge base so that in subsequent runs, it reaches the solution more efficiently. So this is the continuous learning feature that we saw. So let me just run it here. Okay, so we are going to see, as I said, a real-life scenario that we simulated in one of our platforms. It shows the logging of the AIOps system as it detected and responded to a real situation where the system lost connectivity to one of the data centers. This is our email platform deployed in an architecture with 3 data centers. And you can see there in the left the high-level architecture of the system with the different agents involved. So now the anomaly detection system receives service alerts from probes and detects deviations in metrics, KPIs, and transactional logs. The triage agent aggregates, correlates, and summarizes the received alerts and detected anomalies, as you can see there in the logs. The next agent, the RCA agent, gets prompted by the triage agent, and it formulates possible hypotheses for the cause of the issue based on the existing evidence and its knowledge of the system. The hypothesis validation agent elaborates a plan to validate each of the hypotheses formulated by the RCA agent. The agent invokes tools to find if there are any ongoing change requests on the platform and to retrieve load balancer and CPU metrics of the system. The tools report no anomalies in the total volume of load balancer sessions during the incident. But saw an abnormal increase of usage in 82 and 83 at 1250, as you can see there from the output of the tool. So the agent concludes that the hypothesis of a temporary overload on DC2 and DC3 due to the unavailability of DC1 is supported by the observed increase in CPU usage. So the intervention agent queries the knowledge base using retrieval augmented generation for guidance on the suspected data center overload, but it doesn't find any previous knowledge. The intervention agent formulates a plan grounded in the hypothesized cause and the potential impact of the possible actions. And the next best action decided by the intervention agent is to scale up resources. The action is considered safe, so no human confirmation is requested. And after the actions on the platform, the agent decides to perform a number of checks to verify the results. The agent invokes tools to verify the health and status of the service, verify the result of the actions performed from the load balancer and CPU metrics, and forecast metrics for the next hour to estimate the current level of risk and decide whether additional actions are going to be needed or not. The results of the checks inform the agent's next course of action. The actions performed have produced the expected results. The agent decides to continue close monitoring with no further actions for now. And the learning agent documents the troubleshooting session in a knowledge-based article for referencing future occurrences. So initially, a human expert will review and approve the article as part of the feedback for reinforcement learning. Okay, so yeah, this is the end of this demo. I hope the demo has been useful. And yeah, thank you for your,
thank you.
for your time.
Excuse me. I've just one quick question, please, if I may. And that is your system designed to be adaptable and integratable, if that's the word, with other types of platforms beyond messaging?
Yes, so yeah, we can say that an agentic AI system like this has two parts. So one part is more like a framework that provides the key capabilities of the system, like troubleshooting operational issues on any software-based platforms, or doing a causal inference to determine root cause of issues, or perform, as we said before, long-running investigations, understand code, etc. So this part can be considered mostly agnostic of any specific technology. And then there is a part that I would say is very specific to every environment. So this includes all the domain knowledge that we inject into the system, the prompting, all the training of the models, the specific actions, the tools, and the resources that the system has available at each step, etc., etc. So yes, I would say a system like this can be adapted to different software environments, but of course, it requires a significant amount of domain expertise, properly designed by the human experts. And as I mentioned, it requires a non-trivial stage of benchmarking, self-learning, etc. So yeah, adaptable.
Thank you very much. Really interesting as well to hear about real life experience that always beats the theory. Thank you very much indeed.
Okay, thank you very much for having me. Thank you.